Okay, welcome back. So there is one thing that we need to cover for our understanding, and that is the idea of sets as they're being used. Okay, so when it comes to linear independence, how do I say this? When we looked at the definition of linear independence, we look at a set of vectors. We typically use linear independence or linear dependence when we're talking about a set, which is fine, but that's not really the most accurate terminology that we want to use. Okay, because one of the things, the properties of sets is, one is sets order doesn't matter. So the set of 1, 2 is the same as the set of 2, 1 because we're looking at a collection of objects. The other property that we look at when it comes to set, oh, bless you, sorry. The other thing that we look at when we talk about sets is that duplicates collapse, right? So if we have the set of 1, 1, 2, well, that's going to collapse and is equal to the set of 1, 2. Because we don't keep duplicates in a set of objects. But when you're talking about a set like, if we take the matrix 1, 1, 1, 2, 2, 2, and 1, 2, 3, right? We do this operation, right? Now let's say we take 1/2 of row 2, and so now we get 1, 1, 1, 2, oh, excuse me, 2, 2, 2, 1, 2, 3. We can see that this is a linearly dependent set of rows because what do we have? We have the set of 1, 1, 1, 1, 1, 1, and 1, 2, 3. Okay, but if it was a real set, we would say that this set is the same as just 1, 1, 1, comma, 1, 2, 3, right? And so, which is clearly linearly independent. So, we don't want to reduce sets, right? Because when we're talking about linearly, when we're talking about like the Gauss method, you know, we should be able to preserve linearly independence, right? So, set is not not the most accurate term we should use, and because Gauss's method should preserve linear dependence, if there is any. So when we're strictly speaking, we need a type of collection where duplicates do not collapse. A collection, now here's a definition that just to be aware of. And a set, so a set where order does not matter and duplicates do not collapse called a multiset. Now, the standard terminology that we use here is set, and of course if we depart from the standard, that has its own pitfalls. So what we're going to use is we're going to use set as well. Now later we shall occasionally need to take combinations without letting duplicates collapse, and we'll do that without any further comment. So just so you know, going forward. Okay.